Hi, welcome to our discussion on independent events. Now, before we actually start talking about independent events, one thing that I want to emphasize or re-emphasize is the difference between mutually exclusive and independent events. These are two very different things. So, for mutually exclusive, we've talked about this before. Do you remember what mutually exclusive means? Mutually exclusive means that the events cannot happen at the same time. Okay. Another way to look at this is there is no intersection or overlap. There is no intersection or overlap. Another way to look at this is the probability of A and B is equal to 0. This means mutually exclusive. If we look at this visually, if we think about a Venn diagram, this would look like two circles for A and B that don't have any overlap. There's no intersection. If you look at the two lists, there's no elements that appear on both of those lists. If you think of some examples, like being a freshman and a senior. Like, nobody is a freshman and senior at the same time. You're a freshman or you're a senior or a sophomore or a junior. But there's nobody out there that's both a freshman and a senior. You're one or the other. You can't have both. So this is what mutually exclusive means. Now, independence is actually a very different situation. Independent events, if two events are independent, this means one event does not influence or change the other, or the probability of the other. We're going to run out of space. Made it fit, of the other. Okay, so if two events are independent, what this means is the one event does not have any influence on the other event. Notice that's completely different than mutually exclusive. Mutually exclusive is just saying whether they can happen together or not. Independence is saying does one event affect or influence the other. Now, there's really no visual for independent events like there is for mutually exclusive. I can't really draw a Venn diagram and say, this is what independent events look like on a Venn diagram, because actually, to really determine if two events are independent, you've actually got to do some math and you've actually got to do some comparisons. So I'm going to tell you right now that one of the ways that you can tell if two events are independent is if the probability of A given B is the same thing as the probability of A. I'll talk a little bit more about this when I do an example. But basically what this means is B has already happened, and then A happens, but it's the same thing as just A happening by itself, which means B does not change the probability of A. B doesn't even have to be there. We can cover up B, and then we have probability of A equals probability of A. B has no influence on the probability of A. The other way, and look on your formula chart or in your formula booklet, because this is called independent events. This is the formula. This is how IB defines independent events, is if the intersection is equal to the probability of A times the probability of B. So these are the ways that we're going to be able to check to see, does one event influence the other? So I just wanted to kind of make this comparison. Mutually exclusive and independent, they are two totally different things. For mutually exclusive, the intersection has to be 0. For independence, one of these two things has to happen. So totally different mathematically, totally different definitions. Please be careful with these two vocabulary words.